So today's topic, compare natural and forced commutation. What is mean by commutation? In power electronics, commutation is the process of turning off a silicon control rectifier. Its curricular steps for the reliable operation of UCR in applications like inverter, AC-DC conversion and motor control. So, commutation means the power electronics commutation is a process of turning off or turning on. Means commutation. Or what is meant by rectifier? Rectifier means the SCR operations like AC or DC. It is conversion. So, it's called as a rectifier. This process R means commutation. In this process is motor controller. Then there are two types, natural commutation and forced commutation. So first type is natural commutation. In natural commutation, the source of commutation voltage is the supply source itself. It means the voltage supply is itself. Then if the SCR is connected to an AC supply at every end of the positive half cycle, means the SCR connected, it is a positive half cycle, and anode current goes through the natural current 0. So in this graph, natural current will be 0. Then and also immediately a reverse voltage is applied across the SCR. These are the condition to turn off the SCR. It means when current are also 0, then it is also immediately reverse voltage is across the SCR. This condition to turn off the SCR. Then this method of commutation is also called as source commutation. It means this commutation is called as a source commutation or line commutation or class F commutation. This commutation is possible with line commutated inverter control rectifier, cycloconverter and AC voltage regulator, because the supply is the AC source in all these converter. It means natural commutation is the supply of a AC source. We will see in this graph or circuit diagram. Then forced commutation. So, forced commutation is a method of turning off a semiconductor controller rectifier. It means the forced commutation, it is the one type of a semiconductor control rectifier by using an external circuit to force the current to 0. It is external circuit force current, it will be 0. This is necessary in DC circuit because there is no natural current 0. This is the force commutation. So it is a DC circuit. So it is not a natural current 0. We will see this circuit diagram and these waveforms. Then class of force commutation. There will be 4 class. Class A, class B, class C, class D. Then class C. We will see class C. In the context of natural commutation, class C refers to a commutation technique also known as a complementary commutation. In this C class is also called as a complementary commutation, where a second SCR means thyristor, is used in parallel with the main SCR. So we will see in this figure the thyristor is used in parallel with main SCR to turn off by applying a reverse voltage through a charger capacitor, initially allowing one SCR to communicate the other by switching the current path. This method is distinct from natural commutation, which relies slowly on the AC supply voltage reverse to turn off the SCR. It means this commutation which relies slowly on the AC supply voltage and then reversal to the turn of the SCR. Then class D. This also called as a auxiliary commutation. Class D, it means called as a auxiliary commutation. In this, the main SCR is commutated by the auxiliary SCR. The main SCR with load resistor from the power circuit will the diode D, indicator L, and SCR2 forms the commutation circuit. We will see in this diagram the main SCR, it is load resistor from the power circuit, then diode indicated by D, and then indicator it is L or SCR2 forms the commutation circuit. Then difference between natural and forced commutation requires first of all, natural commutation requires AC voltage as input. Then forced commutation requires DC voltage at input. Then natural commutation external component are not required. Then forced commutation external component there are will be required. Then natural commutation used in control rectifier AC voltage control. Natural commutation it is also AC voltage controller. And force commutation it will be used in chopper inverters etc. Means force commutation it is used in DC. Then natural commutation is CR turn off due to negative supply voltage, and force commutation is CR turn off due to current and voltage both. Then no power loss takes place during commutation in natural commutation, and power losses take place during commutation in force commutation. Then natural commutation also zero cost, and force commutation significant cost. Thank you.